The title of the talk is 6 Months Out of This World, which is an experience that I had last year. So I was in space for about 6 months. And I'm going to talk to you about all of this. So this is part, of course, of Science Week Ireland. You know, there is a lot of activities going on here to promote science a little bit, to show that science is cool. It is? Are you crazy? Science is cool, or can be cool, and to be a scientist, you really do not need to be a genius or a crazy guy or God knows what. I mean, regular people can be scientists, and usually they're pretty good. Obviously, I am an astronaut, and I'm going to talk about space and what it means going in space and do activities in space. And the first question that I'm going to ask you is, why do we go in space? Why do we go in space? I mean, it's difficult, dangerous, expensive. Space, it's a place that is hostile to life. You cannot live in space unless you have a machine that keeps you alive. The machine stops working, you're dying. So why do we go there? I mean, we stay home and have a sandwich, maybe it's better. Why do we go in space? Come on, if we keep going like this, huh? To explore. To explore. Curiosity? Well, explore, curiosity is more or less the same thing. To learn, curiosity, explore, learn, more or less the same thing.
Unique environment, free of gravity.
Well, because there is a unique environment free of gravity, yeah, but what do we go there for? All right, I mean, you guys touched most of the items. My answer, yeah, this is not the official European Space Agency or NASA or whatever you want answers. My answer is that we send astronauts to space because it's cool. Because there we find an environment that we do not have here on Earth. Otherwise, why do we go there? This is just like going in vacation. Why are we going vacation in Maldives? Because we go to Maldives, we find something that is not in Dublin. Otherwise, we stay in Dublin. Why to go all the way there for finding the same things? And space is the same. We take all the pain to go down there because only there we can do things that we cannot do here on Earth. For example, we take advantage of the unique environment, which is microgravity, to carry out scientific research. You know, microgravity means a little bit of gravity, or we always say also weightlessness, or we say also 0G, or lack of gravity. In fact, there is a little bit of gravity. But gravity, it's one of the constants here on Earth that you cannot get rid of. There's no way here on Earth you can get. I mean, we have special planes that kind of fall into the sky, but this is like a 20-second fall. So you can have 20 seconds of microgravity, a little bit dirty, but you can have it. But 20 seconds, you can do a lot of things in 20 seconds, but there's still 20 seconds. You need, you know, to grow a crystal, you need a month of as little gravity as possible. So you can only go up there and doing this. So conduct scientific research. Also, because the place there is so unforgiving and is so special, you end up coming up with a lot of technical stuff that then are useful in everyday life. This is always happens when you try to do something impossible. Sometimes you achieve the impossible, but what you really end up doing is make simple things easier. Strangely enough, when we try to do something very difficult, the effect is that the easy things become even more easier. So, because in space it costs a lot to bring up stuff, weight is a premium, volume, strength, power, everything is maximized, and as a result you come up with small engines, small motors, very efficient, with some lubrication that is extremely good, and eventually all of this filter into the washing machine, the cars. Think about the cars, 20 years ago, a car, 100,000 kilometers, you throw away the engine and you rebuild it again, or 5 years later you have a hole in the tank and it was normal. Not now, not anymore. And it's not because we went to space, but going through space and really looking at technology, maximizing things, then these little things come a little bit easier. So it's a very important test bed to carry out scientific stuff. And the last thing, I put it last because this is the most difficult to explain, but it should actually be first. This is the real reason why we go there, is because we want to explore, which means acquire knowledge, which means use the knowledge for us. This is what we do. This is what, as human beings, we actually have ever done in our history. That's why we are not anymore in the caves, or we are not anymore, chasing animals. We still chase animals, but okay, we are not anymore as we were before. Because we like to explore, we like to acquire knowledge, we like to learn things and use them for our benefit. I have a question for you. How many of you have seen Felix Baumgartner, about, what was it, a month ago, when he jumped from 30 kilometers down? Have you seen that? Have you seen it live by any chance? Yeah. So the question is the following. Think a second about this one. How many of you, at the moment this guy was up there and was about to jump, and we would see in the pictures this earth and things like this, how many of you for a second felt a little bit of envy, a little bit, I would like to be there, I'd like to do this? How many of you did that? I bet almost everybody. Now, how many would do it and how many would have the capability, it's a different story. I bet some of you would even do it, but the point that I'm making is that almost all of us, when we see somebody doing something exceptional, something impossible, something that is making our knowledge further, something that where you risk your life, this is kind of strange. We put ourselves, we risk our life to prove something that maybe has no real meaning, and we still want to do it. So this is something we have inside. It's us. It's our nature. Cannot go away from it. This is what leads us to go where nobody, whatever it is, it's the saying. So go there. So we go there because this is what we do. And there are a lot of things, we'll see later, there are a lot of things that we don't know, we want to explore. And space, traveling in space is one of the things that will bring us further. Now, we do fly these days in space, and we do have an International Space Station. ISS stands for International Space Station. It's essentially a laboratory. It's probably from a volume point of view, it's about as big as this room, these two rooms. It's divided into subset of little rooms, kind of corridors, 2 meters by 2, inside these modules. Each one of them is like 10 meters long, more or less. They're all connected, and it makes this T, the central T, it's pressurized, so you are inside. A lot of these are laboratory. This is the European laboratory, Japanese laboratory, American laboratory, Russian part. This is a kind of a service module. So there is a lot of stuff in there. The central truss, it's about 100 meters long. So it's big. It's as big as a football field. I mean, it's a huge piece of, massive piece of equipment flying in space at 400 kilometers above Earth. Why Earth? Why 400 kilometers? Why not 3,000? Why not 150? Why 400? Well, but why did we make it fly at 400 kilometers?
The balance of gravity, no?
A balance of gravity. Well, it stays at 400 kilometers because the speed, the forward speed, balances the gravity and all of this. But why not 600? The shocking. Well, the reason is the reason is the following. It's a simple, relatively simple reason. We want to be outside the atmosphere, because if you will be inside the atmosphere, you will decay very fast, because you're slowing down, and as soon as you slow down, you come down. So the atmosphere, it's said that it's about 100 kilometers, the atmosphere, more or less about 100 kilometers. It's very thin at 100 kilometers. But in fact, the atmosphere extends I mean, up here at 400 kilometers, there's still some molecules, some things. In fact, station falls down about 100 meters per day. So every month, more or less, they reboost it up, then slowly comes down and put it up, and it keeps going like this. So if it would be lower, it would fall down even faster. So they put it at a altitude that it only requires about a month, every 2 months. If one day they have a problem, cannot do a reboost, it can still stay there for a year before falling down. Now, they could put it higher, but then it would take longer and it would be more expensive to go and reach it. So 400 kilometers is a good combination, a good place. Or for example, the shuttle could go to 600 kilometers. You know, the Hubble Space Telescope is 600 kilometers, so a shuttle can go 600, but it costs more fuel. So 400 is a good compromise. It flies around the Earth at about 28,000 kilometers per hour, which means that you are traveling about almost 8 kilometers per second. So if you look down, the Earth is passing at 8 kilometers per second. And every 30, 40 minutes, you have a sunrise and a sunset. That's interesting. Now, 16 sunrises, 16 sunsets per day. Should not look out of the window. It's dark. It's time to go to sleep. Doesn't work. Otherwise you sleep very short and then you wake up very quickly. So it's a very interesting place. And of course, microgravity. There is a microgravity environment, meaning that there is no more gravity. You can look at all little things that here on Earth you can really not do. You can measure. It's a very good place to do experiments. The body behaves in a different way, and we will see later. Let's see. Another interesting things, United States, Russia, 10 nations, 10 countries in Europe, Japan and Canada are the partners of the space station, which makes it complicated. So you want to complicate things, put a Russian and an American, somebody from Europe, somebody from Canada, a Japanese on the same table, and make them agree on things. It's a mess. It's not easy. In fact, it would be much easier. It would cost even less if just one of these countries would do it. But the point is that we want to do an international cooperation. And it turns out that when you put the effort in making something like this work, and you set it up, then that project becomes much stronger than being under the control of one single nation. One of the problems that the Americans don't have a rocket today is because every time a new president comes, cancels what the old one has done and start from scratch. So guess what? Every 4 years, you have a cycle. And projects, from a political point of view, should last no more than 3 or 4 years because nobody cares what happened later. So if I'm a president, I will subscribe to a project that lasts 4 years, and I can get results and show them. But nothing that costs 10 years, 15 years. Why don't we go to Mars? Because nobody is willing to invest, a substantial amount of money with some political results that will be 10 or 15 years down the road. That's the problem. So, but this shows you that when you put effort and energy, then the project is strong. In fact, it would have been canceled already if it would have been only under the control of the United States. But now United States, Russia, Europe, Japan, and Canada, a lot of difficulties, but you get a stronger thing. It shows you also that when you want to do complex things, you can actually put all these countries working together. So interesting also from a political point of view. This is obviously not a picture that's coming from the space station, right? Where's this picture coming from? Space. Space. Yes. Which space? Mars? The moon! The moon! Yes, this is one of the pictures that came from the astronauts who were on the moon. In fact, I was a little kid when these guys were jumping around there, and I was looking at them like, wow, John Young jumping on the moon, riding the lunar jeep, and I want to ride it too. I want to be an astronaut too. I was a little kid. Look how nice I was. Nice little kid in school. I was not too good, to be honest. And this is what was more or less when I wanted to be an astronaut. But things took a different fold, we say in Italy. I don't know if this works. And I ended up going into the army. You know, I was drafted when I was 19. I had to do my 1 year of compulsory military service, and then I decided to stay. I was having fun, doing all sorts of crazy things, like jumping off perfectly good airplanes, which pilots say is crazy. But I was having fun. And then when I was 27, I decided to go back to my original dream and try to really make it happen. It was an impossible dream. You know, at 27, I did not speak any English, studied French in school. I did not have a degree, university degree. I had all odds against me. I know when I presented my letter of resignation to the army, a general called me and says, "You're out of your mind. You're now an officer, special forces officer. You have done a lot of things, blah, blah, blah. And you're resigning because you're telling me you want to be an astronaut. And you don't speak English. And you don't have a degree. And you are 27. Are you all right?" You know, and I said, well, you know, I'll take my chance, or my chances. And in fact, some years later, it took a long time. It did not take a year or two. It took 20 years, actually 20 and more years. There I was, in a very weird situation. I had been assigned, this was my second flight, by the way, I had been assigned to a crew of 3, and the commander was Mr. Colonel Dmitry Kondratiev, Russian Air Force, that wanted to bomb us a few years early. And there I am in a crew with Dmitry Kondratiev, with Katie Coleman, a scientist. She has a PhD in chemistry, but she's also a colonel of the US Air Force, and me sitting there in the red square, putting some flowers on Yuri Gagarin resting place, because this is something that the cosmonauts do all the time before going to Baikonur and take off. They go there, put some flowers on Yuri Gagarin, some other flowers on Korolev. Do you know who Korolev is? So he's the father of the Russian space program, the one that designed all the rockets, the one that really pushed it. And then we took off, went to the Cosmodrome of Baikonur, today Kazakhstan, ready to be launched in space with a rocket. And when I looked at it, I said, holy cow, it's the same one they used for Yuri Gagarin. And it was true. I mean, you look at it, it looks like exactly the same one. I mean, the rocket itself is not far away from that Yuri Gagarin thing. What has changed is the top part here. There is a little spacecraft in here. It's called Soyuz. Slightly different than Yuri Gagarin. Yuri Gagarin had to parachute out of his spacecraft because they didn't know how to land yet. But then they figured it out. So now this one lands. Soft landing. We'll talk about it later. But there I was, same launch pad that Yuri Gagarin used 50 years before. It looked to me the same rocket. I'm thinking, this is crazy. This is crazy. And but it was interesting. It was interesting that I was a little kid and all of these things were happening, and suddenly I'm sitting there and doing essentially the same thing, which was interesting. In fact, we took off. It was 1 o'clock at night, December, minus 23 degrees, I think, very cold. And we took off. You know, I flew on the shuttle before. The shuttle, it's a very powerful machine. Can carry 7 astronauts, even 8. They did a couple of times 8. It can carry 7 astronauts and the equivalent of a double-decker in the cargo bay. Can bring it in space and bring it back. It's a very extremely powerful, performant machine. can do brilliant things, but it's very flimsy. It's very delicate. Anything can disturb the launch, the process, and everything, and it's normal, absolutely normal that you're scheduled to launch today, and then you don't launch today, maybe tomorrow, then maybe tomorrow, maybe tomorrow, and you keep going like this. Oh, and in 6 months. Okay, then you come back 6 months later, not today, not tomorrow. I mean, there is always some problem. It's very seldom that the launch starts on time. This one, it's a very little spacecraft. Yeah? If you are sitting in 3, pull up your legs like this, and look at your 3, that's essentially the space that there is inside the spacecraft. I mean, that's all. It carries 3 astronauts and 1 sandwich. That's it. And though it's extremely reliable, it has like 237 launches and had 1 mishap a couple of times, but not major problems. From a safety point of view, this is much safer than the shuttle, by the way. And it's very resilient. I mean, I'm pretty sure there was some kind of polar bear chewing up the cables somewhere, and they did not care. They launched anyhow. You know? So you are essentially making, the engineers are actually essentially making a little atomic bomb explode here in a controlled way, and as a result, you are thrown in space. This is what happens. That's why it's dangerous, because there is an enormous amount of power that is stored in here and had to be controlled in a way that the result is you go in space instead of being blown apart. And it works, and it takes, how long does it take from this moment to the moment we go to 400 kilometers? Which we don't go up straight, we go up kind of it's like we actually travel 600 kilometers to reach the 400 kilometers altitude. How long does it take, do you know? 3 seconds? Holy cow, 3 seconds, 600 kilometers? Whoa! 4 minutes? What? 7 minutes. What do we have, a kitchen, a recipe or something? Anybody else? Anybody for longer? 7 minutes 1, 7 minutes 2? 3 hours. Okay. It takes actually 8.5 minutes. And by the way, the acceleration and the launch, what you feel inside from the shuttle and the Soyuz is more or less the same. And the shuttle takes 8 minutes and 22 seconds, Soyuz 8 minutes and 30 seconds, so more or less the same thing. The acceleration you feel inside is still you're traveling 600 kilometers. The distance Milan-Rome, I use this in Italy because people know, still did not figure out here which city to take. But let's say Milan-Rome, there is a high-speed train, 600 kilometers, it takes 2 hours and 55 minutes at 300 kilometers per hour. So, of course, he has to stop and brake, but the maximum speed is 300 kilometers per hour. So imagine to do that in 8 minutes and a half. So the acceleration is actually 3.5 Gs. So it's like you are laying down on the floor and you have 3 people piled up on top of you. No, it's not really extremely comfortable, but it's nothing really that you cannot handle. I mean, most of you could handle it, a little bit of training, can handle it, no problem. I mean, so going to space with this kind of things is possible. It's possible for tourists. You know the oldest astronaut flew in space, how old it was? John Glenn in 1999, I think 2000, 77-year-old it was. So 77-year-old guy. One of the tourists that bought a ticket with the Russian, the year before had a quadruple bypass done on his heart. The Russian didn't want him to fly, and he said, well, I paid, I want to fly. So he took responsibility, and they launched him, and perfect, no problem. So it's not anything that you don't need to be Superman or super God knows what. You can fly in space.